Imagine looking up at the sky and seeing not one sun, but two. For centuries, that idea belonged in science fiction. A world with twin sunsets sounded like something invented for movies, not something nature could actually create. Then, astronomers found one. A real planet orbiting two stars at once. And according to everything scientists once believed about how planets are born, it shouldn't exist. Because the region where this planet formed is one of the most violent places imaginable. Two stars constantly pull against each other with enormous gravity, filling the surrounding disk with turbulence powerful enough to prevent planets from forming in the first place. Yet somehow, one enormous world survived, and its discovery forced astronomers to rethink one of the most fundamental rules of planetary science. The story begins hundreds of light years from Earth. Astronomers studying data from NASA's Kepler telescope weren't searching for impossible planets. They were looking for tiny dips in starlight. Normally, when a planet passes in front of a star, the star becomes slightly dimmer. That tiny change reveals the planet's presence. But for one particular system, something no computer expected. The dips appeared, then disappeared, then returned at completely different intervals. At first, researchers suspected an error. Maybe the telescope had glitched. Maybe another star was interfering. Maybe the data were corrupted. Yet every time they checked, the strange pattern remained. Something was moving across two different stars. That had never been confirmed before. The system was eventually named Kepler 16. Instead of one sun, astronomers found two stars orbiting each other every 41 days. One star was slightly smaller than our sun, the other was much cooler and dimmer. Together, they danced around a common center of gravity like cosmic partners locked in an endless orbit. Around both of them, far beyond their chaotic motion, orbited a giant planet. Kepler 16b, the first confirmed planet ever discovered circling two stars. It was a breathtaking discovery, but it immediately created a much bigger problem. How did it get there? Planet formation sounds simple. Dust collides with dust. Small rocks become larger rocks. Eventually, gravity builds entire planets. But that process only works in relatively calm environments. Near two orbiting stars, conditions become chaotic. Gravity constantly changes direction. Objects accelerate unpredictably. Tiny building blocks smash together at destructive speeds instead of gently sticking together. Computer simulations predicted that young planets should be shattered long before they ever became worlds. Scientists even gave this dangerous region a nickname, the Forbidden Zone, a place where planets weren't supposed to survive. Yet Kepler 16b was calmly orbiting exactly where theory said it shouldn't be. Either the planet had somehow ignored physics, or the theory itself was incomplete. Researchers around the world began running new simulations. Supercomputers modeled billions of years of orbital evolution. Again and again, something strange happened. Whenever they started planet formation close to the twin stars, everything fell apart. Fragments collided violently. Growing planets broke into pieces. Nothing survived. The computer simulations matched the old theory perfectly. So why was the real planet still there? Then another possibility emerged. Maybe it hadn't formed there at all. Imagine building a house far away from a dangerous river. Years later, the ground slowly shifts until the house sits near the water's edge. The house didn't appear there, it migrated. Astronomers wondered if planets might do something similar. Perhaps Kepler 16b formed much farther from the stars, where conditions were calmer. Then, over millions of years, interactions with gas in the young planetary disk slowly pulled it inward. If true, the impossible planet wasn't born in the forbidden zone. It simply moved into it after surviving its chaotic childhood. The idea sounded promising, but there was a catch. No one had ever actually observed planetary migration happening directly. It remained one of astronomy's biggest unanswered questions. Then, the discoveries kept coming. Kepler didn't find just one circumbinary planet. It found another, then another. Soon, astronomers identified multiple planets orbiting pairs of stars. Each discovery weakened the old assumption. Twin star planets weren't impossible, they were simply rare. And every new system looked different. Some orbited close to their stars, others traveled much farther away. Some stars were nearly identical, others were dramatically different in temperature and size. Nature appeared far more creative than scientists had imagined, but one mystery refused to disappear. If these planets were real, how many more were hidden across the galaxy? Astronomers turned their attention to an astonishing possibility. Nearly half of all Sun-like stars in the Milky Way belong to binary systems. That means billions of stars exist in pairs. If even a small fraction host planets, the galaxy could contain countless worlds with double sunrises and twin sunsets. Entire civilizations, if they exist, might grow up believing two suns are completely normal. For them, our single sun would seem unusual. It was an idea almost too extraordinary to believe. But as telescopes improved, evidence kept pointing in the same direction. The universe wasn't stranger because of one impossible planet. It had been stranger all along.
The next discovery didn't just raise new questions. It challenged the explanation that many astronomers had begun to accept. If Kepler 16b had migrated inward from a safer distance, perhaps every circumbinary planet had followed the same path. It was a neat solution, until researchers found systems that didn't fit the pattern. Some planets appeared to orbit remarkably close to the edge of orbital stability, as if they had settled into a narrow, safe zone where even the slightest change would send them spiraling into space or crashing toward their stars. It was almost as though nature knew exactly where the boundary was. That forced scientists to rethink their models once again. Perhaps migration wasn't random. Perhaps the swirling disk of gas around two stars naturally guided planets toward these stable locations where gravity from both stars balanced just enough for a planet to survive over billions of years. The more researchers studied these systems, the more they realized something surprising. Chaos wasn't the whole story. Hidden within the chaos was order. The twin stars constantly pulled on the surrounding disk, creating waves, gaps, and shifting patterns in the gas. Instead of destroying every young planet, those patterns may have acted like invisible highways. As a growing planet interacted with the gas, it slowly lost energy and drifted inward. Eventually, it reached the inner edge of the disk. There, the push from the gas weakened. The planet stopped migrating. It remained parked just outside the dangerous region where unstable orbits begin. That elegant explanation matched many of the worlds astronomers were now discovering. What once looked impossible suddenly made sense, not because physics was broken, but because scientists had underestimated how complex planetary formation really is. Then another question emerged. If planets can survive around two suns, could they also support life? Kepler 16b itself almost certainly cannot. It's a gas giant, similar in size to Saturn,
with no solid surface to stand on. But that doesn't end the story. Gas giants often have moons. In our own solar system, moons like Europa and Titan have become some of the most exciting places in the search for life. If a large moon orbited a planet like Kepler 16b, it might receive enough warmth from its stars to maintain conditions far different from what anyone expected decades ago. Even more exciting, astronomers have since discovered other circumbinary planets whose distances from their stars place them near regions where temperatures could allow liquid water under the right conditions. No one has confirmed a habitable twin-sun world yet, but the possibility is no longer science fiction. It's a real scientific question. Every new telescope is expanding that search. NASA's Transiting Exoplanet Survey Satellite, better known as TESS, continues scanning the sky for planets around nearby stars. Meanwhile, powerful observatories on Earth and in space are beginning to study exoplanet atmospheres, searching for the chemical fingerprints of water, oxygen, methane, and other potential signs of habitability. Future missions will go even further. They may reveal weather patterns on distant worlds, measure the composition of alien skies, and perhaps one day detect evidence that life exists beneath the light of two suns. If that happens, it would transform one of humanity's oldest questions: are we alone? Looking back, the most remarkable part of Kepler 16b isn't just that it orbits two suns. It's what it taught us about science itself. For years, the prevailing models suggested such planets couldn't form. The evidence seemed convincing. The equations worked. The simulations agreed. Then nature presented a single world that refused to follow the script. Instead of ignoring the evidence, scientists changed the theory. They built better models, they gathered more observations, and slowly a clearer picture emerged. That's how science moves forward, not by proving itself perfect, but by improving when reality reveals something unexpected. Today, astronomers have confirmed dozens of circumbinary planets, and each one adds another piece to the puzzle. Some are larger than Jupiter, others are closer in size to Neptune. Each system has its own unique architecture, reminding us that planetary systems can form in ways our solar system never could. What once looked impossible has become another chapter in the incredible diversity of our galaxy. And perhaps that's the greatest lesson of all. The universe is under no obligation to match our expectations. Every time we think we've found the rules, the cosmos quietly shows us an exception. Somewhere, hundreds or thousands of light years away, a sky grows brighter each morning, not because one sun rises, but because two do. On that distant world, twin shadows stretch across the landscape, and two glowing stars trace their paths across an alien sky, a sight that once belonged only to imagination, but now is part of scientific reality. Kepler 16b didn't just reveal an unusual planet. It reminded humanity that the universe is far more inventive than we are. And with billions of binary star systems scattered across the Milky Way, the next impossible discovery may already be waiting, just beyond the reach of today's telescopes.